So at this point, we know how to define an array, we know how to assign values into an array, we know the analogies of describing what an array represents and how it stores its memory and what it means to what it actually means to define those arrays. But let's put them to use today. Today we're going to talk about accessing the data within. Now we've already seen that a little bit, but let's go into some more detail on this. So, first of all, we talked about this before, but when we want to retrieve the length of an array, we can just by simply using the length property, the same way we did when we did it for strings. But there's a few things that I wanted to talk about with this. First of all, in the analogy where we had people sitting down at the table, we saw that the arrays aren't always full. There sometimes can be elements that don't have values yet, and that's not a problem unless we make it a problem. So for example, if we tried to display an element of an array that doesn't have a value yet, you're going to run into an issue. If you try, let's say for example, you had a whole bunch of numbers and you wanted to calculate the average number of your array, well, if you have blanks in the middle of it, that's going to be an issue. So there's some things that we need to track. So first of all, if you don't have a full array, you should be manually tracking how many elements there are actually in there. So maybe you create an integer variable and you call it like num elements or size or something like that. And every time you put a new value in the array, you just add 1 to your variable. And that keeps track of however many you have. And that's perfectly good. So then if you want to calculate your average element, you just add up all the elements and then divide by your variable. That makes sense. Now there's other times where your array is actually full, in which case you don't have to track. If you know your array is always going to be full. So let's say, for example, you have an array for your scoreboard and you know there's always going to be that many scores in there. They may get new values, but there is always going to be that specific number of scores in there. Well, in that case, we can actually use the built-in property called length to get the number of elements. And then again, all you have to do is reference the name of the array dot length. That's it. So that's the probably the most important property of this. But what else can we do? Well, how do we actually get values from the array? The same way that we do for regular variables. We just specify its name, but we have to do that added extra bit of also specifying which specific index we want. So in this little example I have here, this one calculates the average element in this array. So I've created a new integer array called nums. And I've set the values when I defined it to 3, 7, -2, 4, and 0. Okay. The next thing I do is I calculated the sum. And you notice for the sum, I literally retrieved every single element one at a time. And then I added them together with the plus operator. So nums at 0 plus nums at 1 plus nums at 2 plus nums at 3 plus nums at 4. For every single one of these, it jumps back to RAM, grabs the proper value, brings it back, and substitutes for each one of these. It adds it all up. And what do we get out of this? 3, 10, 8, 12. Is that right? 12. 12 so our sum is going to be a value of 12. And now we want to calculate the average. Now this is a full array. My array has all of its elements. So I can just divide by the length of the array. So I have sum divided by nums.length. And the beautiful part about this is if I decide to change my integer array and I want, you know what, maybe I'm going to change it to 9 items or 12 items or 2,000 items. I don't have to change this line of code. It's going to work no matter what. The sum is still going to be calculated on the previous line, and the nums.length is always going to be the full length of the array, the number of elements. And then the final output statement just displays those two variables, sum and average, in one single line. Okay, so that's how we access our data. We just simply refer to it by its name and then give it an index. We can do more things though. Now we've recently talked about things called subprograms, and we know that subprograms have we can have procedures and functions. Procedures do a job. Functions do a job and return a value. Both of them can have parameters. A function returns some form of data. Now, we can actually pass an array in as a parameter if we would like. It does have a few differences between the way we normally do things. Now, imagine for a second you're creating a very simple subprogram called calc_rec_area, which calculates the area of a rectangle. Now, if you were to have two parameters for that, which you would, length and width, you would pass in some values for that length and width when you called it. Maybe it's 5 and 2, it doesn't really matter. But the point is you're getting copies of those values. We beat this one to death during the subprograms lesson. It's always a copy of the data, which means if we change the data inside the subprogram, it doesn't affect the original data. That's great. Arrays break this rule. When you pass an array as a parameter, you don't get a copy of the array. You actually get the original array. So what you have is two variables that point to the same memory location. You have the original variable that points to a memory location, and then you have this new parameter that points to the exact same memory location. Well, that can be a problem. So inside the subprogram, if you modify that array, well, the original variable is still pointing to the exact same memory location, which means you're modifying it for everywhere. This could and could not be something that you want. So maybe, for example, you have a subprogram that sorts the array. Well, that's a great feature then, because then you can just modify the array and the original variable is ready to go. You can just use it as soon as the subprogram is done. However, you may have some other things that you just want to manipulate and process the values that you're working on, and the idea of those changes that you make being permanent, may not be something you want. So we have to be conscious of this when we're talking about passing arrays as parameters, okay? You should know that the name of the array for your parameter does not have to match the original array name. It can be completely different. So let's take a quick example of this. In this small program, what I've done is I've created a subprogram called print even numbers. It takes an array of integers and it goes through each one of those integers. There's 3 integers in here. And it says if you're divisible by 2, which means you're an even number, it's going to display that number on the screen. So if numbers at 0 mod 2, which means the remainder, if numbers at 0 mod 2 is equal to 0, it means it evenly divides by 2, then display numbers at 0. And then it does the same thing for numbers at 1 and numbers at 2. Okay. So that's all that subprogram does. At most, we're going to see 3 numbers on the screen at any given time. At the very least, we may see 0 numbers on the screen at any given time, depending on what values are stored in the array. Now let's go up to the main for a second and then see what happens. I've created an integer array called nums, and I gave it the starting values of 10, 7, and 3, or 33. Only one of these numbers is even, so the only number I'm going to see on the screen is 10. Now, how does this work? Well, look down here. I've called the subprogram print even numbers, and I've passed it the parameter nums. So nums points to a memory location. If I could draw this real quick. Let's say this is our, I guess I need to put my pen on. Let's say this is our RAM, and our RAM looks magically just like an array, because really it's kind of the same idea, which is why I do it like this. So let's say this is our RAM. And if we look over here, we created an integer variable called nums, which holds 3 values. So I'm going to say that it takes up these first 3 slots, okay? And this is called nums. And it points to these 3 slots. Now, when we get down to this line, the print even numbers, it jumps down to the signature line. It says, ooh, I got a new variable. I'm going to create a new variable, and I'm going to call it numbers. And then numbers points to the exact same spot. And why does it do that? Because we passed it in as a parameter. So it's saying, point me to the exact same spot. So inside of this code, we're really actually looking at the values 10, 7, and 33. And it checks each one and displays them accordingly. If I had a line of code in here that did something like, let's say numbers at, let's say 2 is equal to 16. That actually will go into the array and modify this 33 to a 16. And then, since I did that before I did all this code, I would actually see 2 things on the screen. I would see the 10 and I would see the 16. And it modified the original variable. So what normally happens to our local variables when a subprogram finishes? They get deleted. Well, are we going to delete the array? No. What happens is when we get to this final closing bracket and it comes back up, this is a procedure, it's not returning anything, it's just a procedure, what does it delete? It's got to delete this. Well, it doesn't actually delete the array. It deletes the pointer to the memory. So it just kills that pointer. So now there's only one thing pointing to that array, which is the original nums variable. So that's how arrays as parameters works. We can do it, and a lot of times it's going to be really useful to do that kind of thing. What about return values? Well, yeah, we can do this as well. So in this example, I've created a function that reverses the order of the array. Okay. Now I could have actually manipulated the original array. So if we look at this function here, down here at the bottom, I pass in the string array called words. Now I could actually manipulate that array itself, but I didn't want to. And the reason why I didn't want to, I wanted to return a new array back, so the programmer would have the option of either overwriting the original array called names or storing it in a different array. So it has both arrays at that point. It has one array called names and another one called reverse list, which is the exact same array in reverse order. Why would I do this? The same reason why when we do string manipulation, we have the option of saving it back into the original string or saving it into a brand new variable. It gives us control over all of the data. And it really depends on the problem of whether you would want to do that or not. But it does give me flexibility, and it doesn't force me to change my original data. So this subprogram doesn't do a lot. It just literally copies the last element of the words array into the first element of the result array. And then it just keeps going until we get all the elements copied around. Okay. So how do we call this? We call it the same way we would call any subprogram that has a return value, any function. We call it by name. We give it any parameters it needs. So just like before, now names and words both point to the same place in RAM. And then when it's all done, it returns the result back up here, which is then copied over to the reverse list. Okay? So if we're looking at our RAM again, well, this is a terrible one. Boom, 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 boom. We have our RAM. We created an original array which took up 3 elements. 1, 2, 3, yep, ish. And it had Bill, Ted, and Bob. There's no way I'm getting all this in here, but we'll try. And Bob. And this was called names. Okay, great. And names points to that piece of data. And then we went down, so that was the first bit. And then it said create another variable called reverse list. So it created another variable called reverse list. You'll notice I didn't specify its size though. All I did was create the array. I didn't do the rest of the definition of the array. That means it's not pointing to anywhere right now. It just says, hey, I promise that I'm going to make a table reservation soon. I don't know when, but I am. So we've basically just created an identifier. It's not pointing to any memory. Okay, let's figure out what happens next. So then it gets down to this line here and immediately jumps down to the signature line of our reverse array. So it creates a new parameter called words. Where does words point? Well, we copied the names into words, so words points to the same place that names points. All right. So now inside of here, we created another array called result. So result, where's result? We'll put result right here. So result, look at what result is. Result has a specific size. We set the size based on the length of words. So we know it takes up 3 spaces. So it takes up those 3 spots. So result is pointing here. There's nothing stored there, but it's pointing there. And then the next 3 lines of code will populate that data. So we would get Bob first, then Ted, and then Bill. So now we have both arrays in there. We have different variables pointing all over the place. And then finally, we return that result. So what does this actually mean? It means if we look at this line right here, we're saying reverse list is now going to point to the same place that reverse array returned back. So that means reverse list points here. It finally is pointing somewhere. But we're at the end of the subprogram. So what happens to all of our local variables? So result and words are both deleted and are deleted from memory. So this goes away. This goes away. So at the very end of this subprogram, at the very end of this code, we have two variables in memory, names and reverse list, that both point to different memory locations and have their own set of data. Hopefully everybody was able to follow that. So now we know how to return values as a function. One last thing I wanted to talk about is something called parallel arrays. Now this is a really interesting concept. Parallel means two things that are in line and they never cross paths. They work together, basically. So parallel arrays are when you have two or more arrays that are related and their data lines up by index. So for example, you may have an array of names and another of scores. You see this on the right-hand side here. So they then work together to store a complete high scoreboard. If we look at this, we have all of our names, Judy, John, Jack, Jill, and Jorge. And on the right, we have scores, 853, 746, 743, 312, and 74. So Judy has the score 853. John has a score 746, and so on and so forth. They line up. So we've created this connection between the two. Okay? And then, so this means index 0 in both names array and the scores array is the data for the player in first place. Now, just to demonstrate how this works, down here below, I've created a quick little chunk of code that prints out the entire high scoreboard. So what would it look like when this code run? It would actually display something like this. 1 dot, the names array at index 0. Well, that's Judy. Plus dot dot dot, plus scores at 0, which is 853. And then it would go down and do the next output line. 2 dot, John, dot dot dot, plus 746. And it would continue on just like that. So we would get a nicely formatted high scoreboard. So these things are working in parallel. 5 lines of code to display the entire thing in a neatly formatted way, as opposed to 10 separate variables if we weren't using arrays. Okay, so that's all that we're going to talk about when it comes to arrays. When we get into the grade 12 course, we're going to go into a whole bunch more, but for now, this is the whole kit and caboodle.